In this video, we're going to be doing some schema design and data modeling for our inbox messaging application. When you're doing data modeling in Cassandra, there are essentially three different steps involved, right? You start out with the conceptual data model, and from there you go to the logical data model, and from there you go to the physical data model. You might skip one of these steps if you feel like, yeah, I kind of get a sense for what this is. So these are not very strict and you don't have to follow them. But these are recommended so that you get a nice progression of your thoughts in terms of what your application needs are to what are the actual Cassandra tables that you're going to create and use later when you're building the application. So let's look at these three phases, right? First is the conceptual data model. A conceptual data model allows you to identify what are the important concepts and things and entities and their relationships between each other, right? So this is typically referred to as the entity relationship diagram in the relational database side of the world, right? So you have ER diagrams where you talk about like, who are the main actors in this thing, right? You're building a messaging application. What are the main things? What are the main actors involved? You have the user, first of all. You have email or the message as another entity, another thing. You have relationship between user and messages, right? A user can have multiple messages. A message can go to multiple users, perhaps. With this application we're building, we talked about folders or labels, right? You can have a message belonging to a folder, right? So things like that. So you have entities or the main actors or the main things involved, and then the relationships between those. So that's the conceptual data model. The conceptual data model kind of allows you to identify what's going on in your app. Like, what are the things you need to be concerned about? What are the things you need to be worried about? That forms a good next step to the logical data model, but it's important to have this high-level conceptual data model. I'm going to draw a few important entities and relationships here. This is not going to be strict ERD diagram, okay? So if you're an ERD diagram purist, you're going to go, well, no, that's not, draw that line there. Well, I'm using a very informal mechanism here just for my understanding of what are the important things that I need to worry about, right? So we're going to start out with the main actor, which is the user, right? User is the primary entity, or the primary thing, and the user has a bunch of messages. So I'm going to have message over here. So the user has a many-to-many relationship with the message, right? A user can have multiple messages. A message can go to multiple users. So it's a many-to-many relationship. So I'm going to say N and M over here. And then this is, I would say, C's or seeable, or, something that the user has access to, because a message can be something that the user sent or the user received or the user was in one of the two lists of, right? So there are different ways in which a user can access or can see a message. So that's this relationship over here, right? There is another entity, which is the folder that I just talked about, a folder or a label. So a label or a folder, I'm going to use these terms interchangeably for this series, so please bear with me. So a user owns a label, right? And a label or a folder can belong to just one user. So this is more of like a one-to-many relationship. One user can hold multiple labels or folders, but a folder or a label can belong to just one user. Just because there is a folder called inbox, it doesn't mean that it holds all the emails for every inbox of every user, right? It's associated with a single user. So that's what this one-to-many relationship is. Now, each of these entities has properties, and you usually annotate it in the ER diagram with this circle kind of a thing. You have the ID for the user, right? And then you have a message has an ID as well. Message has perhaps a subject. It has the body. It'll also need like the from and the to, who sent the message and who it was sent to, right? From and the to. And then the label can have name. It can have some kind of a color indicator, right? So inbox is blue, sent item is green, whatever, right? Done items is green, whatever. So you have some kind of a color indicator to indicate that, okay, this is a certain label which has a certain meaning for the user. Now, these are some high-level properties. The other question, which is what I was tackling, is, do you want to have a message belong to just one folder or to multiple folders? That's a relationship between these two guys. label, and a message. They have a relationship too, all right? So this relationship, I'm going to make it as a message is associated with just one label, with just one folder for the purposes of this Code With Me series. But I'm going to build the schema in such a way that it is extensible, right? So this one, a label, a message belongs to, or I'm going to call it associated with, because it works both ways, right? A label is associated with a message and a message is associated with a label. And I'm going to make this many to many for the purposes of schema design, but I'm going to build it as one to many. You're free to take that code base and extend it to many as well, if you so see fit. So this is going to be the other relationship. So this is the high level entity relationship diagram, the ER diagram. And this is what is referred to as the conceptual data model. If you have attachments, the attachments would be to this guy over here, to the message, right? You can have attachment files, go to a message, and then each attachment would belong to a message, and a message can have multiple attachments. So that would be a one-to-many relationship there as well, right? Now, this is the conceptual data model. And from here, we're going to go to the logical data model. Now, with the logical data model, in a relationship, in a relational database, you again go from the conceptual data model only, strictly from the conceptual, like what are the core entities, what are the core relationships? Let's build a data model from that alone. But that's not going to work in Cassandra data modeling. With Cassandra, what you do is you say, okay, I got a sense for what the entities are and what the relationships are. But now let's look at the application. What is the application looking for? What does the application need? And we're going to go from there, right? So let's say for our application, first page, you need to have a list of folders on the left-hand side, and then a list of messages on the right-hand side, which means that what you're going to do when the home page loads for a user is, given a user, you're going to say, hey, give me all the folders that belong to that user, and give me all the messages that are associated with that first folder that you've selected, and it's going to show that, right? With the logical data model, you're going to come up with these data structures which are a part of the application workflow, right? You have an application workflow where you're going to show folders and emails. You're going to have a data model where you can look up folders for a given user. You can look up emails or messages for a given user, right? So that's going to be the data model that's going to be what is going to govern the approach that we're going to take, right? So what do we need? We need to show the list of folders. So given a user, we need a list of folders. So we're going to build a Cassandra data structure, a table for that, right? For showing a list of folders given a user, right? So I'm going to have a block over here. I'm going to call this folders for user. So this is going to translate essentially to a table in Cassandra, all right? So there are 5 folders associated with the user. It's going to be 5 rows in this table for that user ID, okay? So it's going to have the user ID here, okay? It is going to have the folder name, a label, and it's going to have information about that folder, maybe the color of that folder. And what else do we show when we are showing the folder? We are showing the number of emails that are unread, right? Because that's another thing that's part of the UI, right? If you look at the UI here, we're going to be showing the number of unread messages as well. So that also needs to be a part of that data structure that we are saving. So it's almost as if you're building the perfect response that you need to render that UI in the database, right? If you were to say like, okay, I'm rendering just this particular UI, what would be the ideal database table for rendering this UI? I'm not going to bother with joins. I'm not going to bother with mixing 2 data from 2 different tables. And I'm not worried about any of that. I have this UI, like in a perfect world, what should be the table that's going to feed data to that UI, right? You're going to build that perfect table over here, right? You make your database schema and your data model in such a way that UI is going to load really fast, right? That's the way you can scale things with Cassandra. And the way Cassandra works, this is possible to do without some of the adverse implications. Like if you were to do this in a relational database, you're going to be in a whole lot of trouble, right? So this is going to be my first table. So this is going to have all the information that I need to render the folder view. Okay. So here I'm going to denote what are the primary keys and what are the partition keys. With Cassandra, you're going to identify one of the columns as a partition key, right? This is what is going to influence which node a certain data element is going to go to, right? So I'm going to have the user ID as the partition key here, which means that for a given user ID, all of the records are going to go to that node. Now, why is it important? Because when somebody logs in, you're going to show all the folders for that user, right? Now, if all the folders for that user is not in one node, but it's scattered across multiple nodes, then to show all the folders for a single user, you're going to have to hit multiple nodes, but that's not good. So you want to have all the data associated with a single user's view to be in a single node. Having that entity, that data element as the partition key is going to allow for it. So just by the fact that I have the user ID as the partition key here means that all of the folders for this user is going to go to a single node. It's going to be partitioned to a single node. Of course, it's going to be replicated and it might be copies of it in other nodes. But again, the data that's associated with that user is going to be guaranteed to be in one node only. It doesn't have to hit multiple nodes to get that data. So this helps. Now, another thing that you can do with Cassandra when you're doing data modeling is you can set certain elements as clustering columns. Okay, clustering columns allow you to say, hey, this is also part of the primary key, even though it's not the partition key itself. And one of the advantages of a clustering column is you get, first of all, like you have another record that you enter, right? So like, for example, I'll give you this example here. So let's say I have user A and then folder FOL1 and then color green. Okay. Let's say I create another record, right? So I say, yeah, I want to write this record, user A, FOL1, and then blue. This is going to be an update if this whole thing is the primary key, right? Because it detects, okay, this is the same primary key. This is not another entry. This is basically an update. Okay. So you don't want a same user to have multiple folders with the same name. It doesn't make sense. So it makes sense for you to have both the user ID and the name of the folder be the primary key. And I do that by not having the folder name be a partition key because I don't want different folders to go to different partitions. So what I'm going to do instead is put that as a clustering column. One of the advantages of a clustering column is that you can make this sortable. You can sort clustering columns and it gets sorted while you're writing. So when you're fetching, it doesn't have to do the sorting. So the user name, the user ID is the partition key. The label, the folder label is the clustering column. Those two together form the primary key for this table. All right. So that's the folder for user. Now, how about showing emails? When somebody loads a page, a certain folder is selected by default, and you want to show all of the messages for that folder. So basically what you have here is not only the user ID, but you also have the label or the folder, and you want to get all the emails for that, right? So again, you want to have all those messages for a given user and folder combination to be in a single node. So what are you going to have as a partition key? The combination of the user ID and the folder label, right? So this should be simple now that you understand the concept. I'm going to have messages, user, and folder. All right. There's the convention is to use the word by to indicate this. So here I'm going to change this to by as well, because that's how you, the typical convention is the thing that you're fetching by the thing that you're fetching it with, right? The partition key or whatever you're using to look up that information. So it's going to be folders by user, right? Similarly, you have messages by user folder. So what are the partition keys here? You need the user ID as a partition key, and you need the label, the folder label as the partition key. So these two are going to be partition keys. Now the message ID is itself one of the properties here, but it's not going to be a part of the primary key, obviously, because we want multiple messages to be associated with this user ID and folder label combination. Now, one of the things that you do with an email application or a messaging application like this is show messages in reverse chronological order, right? Which means that there is some kind of a sorting requirement. Now, Cassandra doesn't do sorting when you're fetching, right? You have to define your data model in such a way that it is sorted based on a certain clustering column, which means that we're going to have to introduce a timestamp column as a clustering column, all right? So these two are going to be the partition keys, and this one is going to be the clustering column. The timestamp clustering column is going to be descending sort, right? It's going to be sorted in descending order because you want the newer messages to show up at the top, right? So this is the timestamp clustering column, and these together form the primary key for this message by subfolder table, right? So we have the message ID. Now you can, of course, create a separate message table and look up the message details when you're showing the list of messages. Because, what do you show in the list of messages? You show the subject line, perhaps, who sent the message, perhaps, and when it was sent. That's going to show up in that listing. Now, do you do a join at runtime? Well, again, no joins with Cassandra, right? You need to provide all the data that you need for rendering this, right? Imagine the ideal table for rendering that view. It would have all the things that you need to show in the UI, right? So we're going to design that. We're going to have a to column over there. We're going to have a subject column over there because we need all of that to show the view, right? And we also have the is read column. Now this is read flag is going to indicate if that message has been read by that user or not. So it can show up in bold, or if the user has read it, it shows up in regular font. A lot of messaging applications do that. It is also tied with, I forgot to mention the count, right? The unread count. We talked about how every folder needs the unread counts. We need to add that in this table. So this is read is going to be tied to that unread count. So if some message is read, the is read flag is going to become false for that thing, and that count has to decrement by 1. All right, so those two are tied. So this itself is going to give us everything we need to show the list of messages when a user is clicking on one folder and they want to see all the messages. It not only shows the list of messages, it also has the right order for it because we have this as a clustering column, and it's going to be in reverse chronological order because it's a timestamp. So descending order sorting of timestamp is going to give us the kind of sorting behavior that we need. All right, so this is the message by user folder. Now the user sees a list of messages and they click on one. What do? We show the message details page, right? So we have a given message ID and we want all the information about that message. So we have the message ID coming from over here, right? We have the message ID here, which we need to show the message when the user clicks on it later, right? So we take that message ID and again, go back to the database like, okay, user clicked on this message. Give me the message details, right? So we have a need for a table which returns the message details given an ID, a message ID, okay? So we're going to do just that over here. I'm going to have a message by ID. If we are looking for something by ID, you can skip the by ID in the name. It's again, the convention is if you're looking for an item by something else, then like in this case, right? Folders by user makes sense. Message by ID, well, it's common to look up by ID, so you can technically just call this message. That is fine too, all right? So what do we have over here? We have the message ID, which is going to be the partition key, as you can guess. The from, two is probably going to be like this list of names because a message can go to multiple users. So these are all going to be user IDs that we have used elsewhere in this in the schema. So I don't think we need a separate user database because it's GitHub authentication. If you want to store user information like the user's name, preferences, and all that, you would need a separate user table. But right now I'm just mapping it to a user ID string, right? So you have the from and the to, the subject, and the body. And if there are any attachments, you would store the attachments over here and perhaps have the attachments be in a separate Cassandra table and map it to an ID. But I'm not going to tackle attachments for this code with me series, right? So you have the primary key over here, the partition key over here, which is the message ID. And that's about it. I don't need any sorting because what we're doing here is looking at a single message on its own. So we don't need any sorting. We just need one partition key and that should be it, right? So these are the three kind of tables in Cassandra as a part of our logical data model, right? This is our logical data model. So this data model may or may not map exactly to Cassandra tables. There is one tricky aspect here, which I want to highlight, which is this guy, the unread count, number of messages that haven't been read. Now, how do you tackle this? In a relational database, what do? You mark something as, okay, you have a certain message, which is just been read, okay? You have this message, which has just been read. So you're going to mark this as false, perhaps. Okay, this message has been read. And in that same transaction, you're going to decrement the email count for that particular folder that message belongs to, right? You make it a part of a transaction so that when you mark this as unread, you know that you're updating the right value in the other table, right? That is in a relational database. You have asset guarantees there. Now we are looking at Cassandra. You don't have the concept of you technically have the concept of transactions, but I don't want to use that, right? It's a distributed database. I don't want to bring in the limitations of a relational data model, a relational database, just so that I have this transaction and I want to make sure both these things happen at the same time, right? So this is read, can be updated somewhere else. And now I'm going to go get the unread count, decremented by 1 and write it. And by the time I'm writing it, somebody else has, that is the same user, not somebody else. The same user has read another email, right? Now I'm going to go update this. Now things are not the same anymore. The same unread count is not, applicable anymore. It has to reduce by 1 more. So that's going to be a problem, right? How do I do this? How do I manage counters in a distributed database? Well, Cassandra has a concept of a counter. You can create a counter column and make sure that that counter is decremented. You can write SQL queries so that the counter gets decremented and incremented. But there are limitations to the counter, a table which has a counter. When you create a table that has a counter, you cannot have any non-counter columns which are in the primary key, right? It's kind of a restriction for it. So you have a primary key, you have a partition key. You can create a table which has just a primary key and the counter column. You cannot have another column which is not a counter and not the primary key, right? It's not going to work. Cassandra is like, yeah, I got this. I'm going to take care of the increment and decrement, and I'm going to make sure it works in a distributed database model that Cassandra is. You just cannot have any other column which is not a counter column, right? As long as you do that, it's perfectly fine. So we're going to do just that. Here, we have a folder by user table, which kind of breaks that, right? This is going to be a counter column, right? Because we want to maintain counts, but this is a non-primary key, non-counter column. It's not going to work. So because of this reason, we are going to create another table specifically for managing counters, right? So this is what the physical data model is going to look like. This is literally the tables that we're going to have in Cassandra. And this is what this is going to look like, right? First, we are going to have folders by user, and this is going to contain the username, user ID, which is text. It's going to contain the label, folder label, which is also text, and color, which is also text. It's not going to contain the counter, right? We need a separate table for the counter. So there's going to be the partition key. There's going to be the clustering column. We can't have it sorted. All right. So this is the folder by user. Now I need to have a separate table for keeping track of the unread email. So I'm going to call this unread email stats, right? Or unread message stats. Again, I'm using email and message interchangeably in the series. So again, you have the user ID, which is text, and then the label, which is also text. You need the same primary key as this guy, right? It's just that you cannot have another column, which is not a counter. So I need one separate table just for managing the counter. So I'm going to call this num 100, which is also text. Now this is going to be the partition key. This is going to be the clustering column. And this is going to be this is going to be the counter. Now with these two tables, I'm able to effectively manage the number, tracking the number of read and unread messages. Well, this is going to be a little bit away from our ideal. And I talked about having the ideal table for getting data, right? We want to show a list of folders. Having everything in one table would have been perfect, right? Just give the username. It's going to give you everything you need to show that view. But this is not ideal. This is necessary because we have this unique situation where we need to track the counters, right? The number of 100 messages. And this is the only way you can do it in kind of a distributed database like Cassandra without introducing all the ACID restrictions. So what's going to happen is when you load the page, the inbox page, you're going to be making a call to these two, right? I'm going to call this Q1, which is the first query. This is when you're loading the page, which is the inbox homepage. Okay. Now from here, you also need to show what's on the right-hand side, which is emails by the user folder. Some folder will be selected. It could be the default folder that gets selected when the page loads, or it could be something that the user clicks on. All right. So when some user clicks on a folder, we want to show emails by user and folder. All right. What do we have here? We have the, again, user ID, which is going to be the text, which is the primary key. We have the folder label, which is the text, which is also part of the primary key. So these two are going to be the partition keys, right? Both of them are part of the partition key. And then we have the timestamp. So here's the thing about the timestamp. You want the timestamp to be unique. You have a need for the timestamp, and you also have the need for the message ID. You see here, we need a timestamp, and we also need a message ID. Now, you can technically get two birds with one stone here by using the time UUID. So Cassandra has this concept of a time UUID, which is basically a unique identifier, which has meaning in time, right? So let's say I create a UUID now, which is a time UUID, and I create a UUID later. They're going to be unique because they're UUIDs. But since they're time UUIDs, you can tell that this one came first and this one came later. You can sort based on them, which is perfect. This is what we need, right? We needed a UUID to manage the IDs. And we also needed a timestamp for sorting. Well, if the ID can be sorted, well, why need a timestamp? So that's what we're going to do. We're going to use the time UUID over here. I'm going to call this ID, which is going to be time UUID. And this is going to be a clustering column, which is sorted in descending order. So this is going to take care of both having a unique identifier as well as having it make sense in terms of time. All right. So the remaining stuff, we have the from, we have the to, which is text. We have the subject, which is also text. And we have the is read, which is a Boolean. All right. So this is going to be my emails by user folder table. And people can get to this from over here, right? They go from the page, from the home page. It needs to basically show two things. It needs to show the folder by user and the unread counts to get the left-hand side. And then it has to show the emails by user folder on the right-hand side by default to begin with. But then you click on another folder, guess what needs to happen? It needs to come over here for that user and that folder, give me all the emails. All right. That's the next step in the user flow, the user application workflow. All right. Now from here, User clicks on one email, one message, and they're going to see that message. All right. So let's write out the Cassandra table for that. We're going to have the emails or messages table. All right. So this is going to be having the same primary key as this guy, right? We had a primary key time UUID. So we're going to track with that same ID, which is going to be time UUID, but this one's going to be the partition key here, right? That's going to be the only partition key. And then now we have a list of both the email details. That's what we have a from, which is text. We have to, which is going to be a list of text. All right. Cassandra has the concept of a list, which can take a bunch of different text elements, which is what we need, right? And a message can go to multiple receivers. So we need a list of text over here. And then other related stuff to the message. We have a subject, which is also text. And we have body, which is text. All right. So this is the messages table, which is fairly simple. All right. So this is our database schema / data model. And we're going to be using this for creating our application, right? This is a great starting point for actually going and creating SQL statements and creating tables in Cassandra. But we're not going to be doing that. We're going to be using Spring Data support, which allows us to create entities and put annotations on them, create Java classes, put annotations on them. And then we rely on the Spring Data framework to go create those tables in Cassandra, all right? So with this set, now we're ready to actually get things going, right? Enough of whiteboard stuff. We're actually ready to make things happen. And we're going to start by creating our Apache Cassandra instance on DataStax in the next video. We're going to create our Cassandra instance and we're going to have it ready. We're going to create a key space, have it ready so that we can start writing our Spring Boot application to connect to that, right? We'll see you in the next video.